Okay, have some highlighters ready because this is it for before we go for the weekend. Okay. So I like to highlight trimmed mean, so you know we covered it. Uh, I'm gonna often use letters TM, right, to refer to the trimmed mean. So the trimmed mean, the name kind of refers to it already. We're gonna remove, we're gonna trim, we're gonna take stuff out. Okay. Uh, so in some of the questions, when we actually calculated things, the average was distorted or skewed because of the outliers. Page 29. Have you heard of the word skewed? Something is skewed if it's not quite uh, depicting something that's accurate. If you're biased, that would also be saying, hey, you're biased towards one thing or the other. If you include, like, let's say if we did the income of this class, the average income, and they included my salary, would that be accurate? Would that be like, hey, most students make, right? I don't even know what it would be, but I make the big bucks, right? But that wouldn't be quite right to include me. It wouldn't. See, that's agreeing with me too. So what would you do with my salary? You would remove it, right? You would not include it because then it's not that's skewed if you include me. It's distorted. I hope you get the point. Um, we're gonna say again an outlier. We're gonna talk about outliers again. I have been talking about it. An outlier is significantly different than the general trend. So you're gonna have to be able to spot outliers. Okay. Sometimes there's more than one. And here is where I use my third color. The trimmed mean may be more representative of a measure of central tendency. Okay, why? Because the trimmed mean is found by omitting an equal number of values from the upper and lower ends of the data. That's very important. Okay, what does it say here? Where's my finger right there? Maybe my pencil, because my finger covers the whole thing. Equal number. You can't just trim one on one side and then two on the other side. You have to trim the same amount from both ends. Okay? Here is trimmed mean one more time. Okay? How about we just go and highlight the trimmed mean part? It's there, right? Disregarding equal number of points from both ends of the range. Okay? Now, why do I have that picture there of the judges? Do you think judges could be biased when they score someone? In the Olympics, have you ever watched the Olympic scores at the bottom? Have you ever noticed them being crossed off? Some of them. I don't know if you've ever noticed it. I didn't know about it until just recently. But let's say you're a Canadian athlete, and in the crowd there's an American judge, and that judge just can't stand Canadians, right? You do your performance, and that judge could be saying, "Hey, I'm gonna give that Canadian a 2 because I just don't like Canadians," right? So there's some bias in there. And then there's another Canadian judge in the panel. It's like, "Hey, I love Canadians. I don't care how well you did. I'm just gonna give you a 10." So now you have a problem, right? This one is pulling it up. This one is pulling it down. So what do we do in the Olympics? We say, well, let's remove that one and that one. Let's remove the highest and the lowest and just consider everything else. Yeah. And it could be that athlete deserves a 10, but to remove bias, they're just going to say, let's just for everybody remove the lowest and the highest. So if there's someone trying to be mean to you, we're going to remove that, but we're also going to remove the one that's trying to inflate your mark. And then you're left with the rest. And they do that with everybody. So that's removing bias to the best of their abilities. Okay, and you know what? For the most part, judges are selected for their expertise, and you hope that most of them will score it according to what it actually should be, right? This is a little extreme, right? If you see a 2 in there, you'll be like, wait a minute, right? Like, but I just wanted to illustrate and make a point here, okay? Trimmed mean. Can you get rid of the 10% here? I didn't mean that to. We're not going to have to worry about what percentage we're trimming. We're just supposed to remember that we are trimming, okay? So you remove this and you remove that. Okay. This is upper and this is the lower. So to trim, you need to take the same amount off on either side. Some examples, I'm just going to highlight that one more time. In the Olympics, right, we try to remove bias. You remove bias by doing that. You don't want data to be skewed, so you remove that. Production levels of a company, right? Let's say when I worked at KitchenCraft, one day was a good day. I loved that day, but the bosses probably didn't. But the transformer blew on the whole plant, so there was no power. So we all were outside in the parking lot waiting for them to fix it. It ended up taking the whole shift, like 8 hours. We were just sitting outside. Some people were throwing the football. Good thing it happened in the summer. But anyways, but the company probably wouldn't want to include the zero production that day, right? Because it would be skewed. It wouldn't accurately depict what's happening on a regular basis. I'm repeating myself a lot, I know, but I'm trying to make a point, so let me be, okay? Next. We're making it through this page. We're done for today, okay? But you need to pay attention for this part. I will say this, right? How trimming, right, affects the MCTs, the mean, median, and mode. For this exercise, we're only going to pay attention to the mean and the median. The mode is only affected, follow me on this thought, the mode is only affected if by trimming the data, your mode happens to be in that trimmed piece, right? That could affect it, but overall, usually not affected. I'll just make a note here. Usually not affected. Just make a note of that and a little cloud. So you're probably dreaming of the weekend, right? So there's that cloud there. So there it is. Determine the mean and the median for this data set. Okay. Before we do that, you will just trust me. You'll follow me. I don't want you to spend too much time on this because I know you know how to do it. When you look at this data set, it's arranged, correct? Just make sure you check. It does go up. Do you notice an outlier? Which one is it? 20.2. I just want to make sure you're awake. Yeah, there's definitely an outlier there. That's your outlier. When we include everything, that's what we used to call the arithmetic mean. So I will actually add this. Arithmetic mean, right? So it's still the average you did all up until this point, because we always included everything, correct? Every once in a while I said, hey, remove the outlier, but usually we would include everything. So I call that the AM, right? The arithmetic mean. So let's figure out the average here. Arithmetic mean, if you add everything up, let me just get to the right page here. If you add all these numbers, you get 41.7. And we divide that by 2, 4, 6, 8, 10 values. That gives me 4.17 units. Okay. Question. Do you think this mean is higher than it should be? What is this outlier doing to the mean? Remember the cowboy one, the lasso? Where is that? It's going to take me a while to find it probably. On page 10, when you have an upper outlier, it pulls the mean up. So you should be able to think of that as you're doing this exercise. Okay, so what's the median? This is an even set. So we have to get the median. Let's just do this in our heads. If it's 10, right? 10 divided by 2 is? So we would do the 5th and the 6th divided by 2, correct? Let's count. 1, 2, 3, 4, 5, 6. So I'll just go 5th and 6th. That's 2.3 plus 3.1 divided by 2. I'll just give you the answer. That's 2.7 units. Okay. Let's do one more. I'm going to scroll down here. So let's say determine the mean and the median after trimming this data set. So we want to remove this outlier, correct? I don't want this one. The trimmed mean tells me, you can't just do that. You must also remove one on the low end. Okay. So this is the outlier, remember. This outlier, you want it to be gone, but you must also take the lowest number. This is not an outlier, guys, because this one was close to 0.9, like these were close together. I want to remove this, also have to remove that. Okay. Now, this is not just any mean, this is now the trimmed mean. Okay. Trademark. No, I'm just making stuff up. Trimmed mean, right? Let's find the trimmed mean. How many values are left, guys? 8, right? We removed 2, so we're down to 8. And if you just add these numbers up, you get 20.8. Let me just make sure you understand. This part right here adds up to 20.8. There's a shorter way of doing it, and you will see later. The best way to do it is probably just take the 41.7 and just subtract these two numbers from it. That's probably faster. But right now, just stick with me to make my point. When you do this, you get 2.6 units. You notice the difference? It's a big difference, correct? Is the outlier gone? Here, when we do this, the outlier is no longer considered, correct? Okay, let's do the median. Is it still even? Still even. What do you think the median is going to be without calculating it? Same? It's going to be the same. Let's just do a little experiment. If it's these two, if we cover those two, there's 3 this way and 3 that way. So it's going to be the same. But just in case you don't believe me, what's 8 divided by 2? That's 4, right? So I'm going to have to take the 4th and the 5th and divide that by 2. So let's count. 1, 2, 3, 4th, and 5th. It's exactly the same two numbers as I had before. And I'll just write down 2.7. I think what I'm going to do is I'm just going to stop there. I'm not going to do it one more time. I was going to now trim 2 on either end, but there's not going to be a whole lot of change happening here because the outlier is now gone. So can I just ask you to just, I don't know what you want to do. You want to color it or just omit? Okay. And let's just talk about the mean, the average. So this and this I want you to compare. Has there been a change? Mean has been affected by removing the outlier, by removing the outlier. The median remains unchanged. And I will give you my illustration here. The best I can come up with, right? So this tape has been with me for about 13 years already that I've been teaching. And I want it to last until I retire, okay? So if this is my piece of tape, this is my data set. This is my median. How do I know it's my median? Because I can fold this piece right along that line and have the same amount of data on either side, right? Would that make sense? My median is right down the middle. So if I fold it along the middle and I remove the same number of values on either end, and remember I want this to last till I retire, so I'll just take a little bit off. Right? My middle has not shifted. It will not change. The median stays the same when you trim, because as you get closer to the middle, the more you trim, it doesn't affect your median. It stays what it is right from the beginning. I hope that makes sense. Right? So what I want you, all I'm going to say is I'm going to post a few more questions that don't deal with trimmed mean. I just want you to come back next week. But if you want some more practice on, finding the mean median mode with some negatives and positives and what have you, I'm going to post pages 26 to 28 for you to try. Okay. And other than that,